So today we will start our new topic, which is basically the Coulomb's law. So first of all, you must understand that this Coulomb's law is basically for the point charges, and we have discussed that what are points charges in our previous video. Right now, moreover, these charges must be stationary, like these must be in rest. They must be in rest. Now let's look at what is the basically statement of this Coulomb's law. The magnitude of this electrostatic force is directly proportional to the product of charges and inversely proportional to the square of distance. Now let's see what actually this law wants to state. Consider that here we are having two charges, right? Then, okay, you must remember that the line must be joining from the center. The force of attraction, or the force that basically the electrostatic force, must act on the line joining on the center. Now this electrostatic force is basically directly proportional to the product of charges. It means its force is directly proportional to Q1 and Q2. The electrostatic force is directly proportional to the magnitude of the product of charges and inversely proportional to the square of distance. So this is basically the statement of Coulomb's law. When we combine this statement, it becomes like this. Right? Like this. And when we remove this proportionality sign, we get introduced to a constant which is known as K constant, Q1 Q2 upon R square. Right? Now basically this K is Coulomb's constant. K is basically Coulomb's constant, and it is basically medium dependent, right? Let's find out the value of this K. So basically the value of K is equal to 9 exponential power 9 Newton meter square upon Coulomb square. Right? This is the basically unit of K. So the value of K is 9 exponential power 9 Newton meter square upon Coulomb square. Remember one more thing, that the force is basically equal to minus, okay, this force is on 1 2 force 2 1. What does that mean actually? It means that the force on the charge 1 applied by 2 is equal in magnitude but opposite in direction to the force that is applied on 2 by 1, right? So it means here the Newton's third law is valid. Newton's third law gets valid in this, right? So it means that the net force over here will be equal to 0. The net force equal to 0, and this is basically the medium dependent force. It is a medium dependent force. Okay, when we say that the force applied on 1 by 2 is equal in magnitude but opposite in direction to the force applied by 2 by 1. So it means that is it like so that acceleration on 1 2 will be equal to minus acceleration on 2 1? So not at all, because I haven't said that these both charges are identical. they can vary in mass as well. So this condition doesn't exist, right? Okay, basically the value of this K is calculated by torsion balance. By torsion balance. Okay, there is another value of K which is determined through the formula, which is K is equal to 1 upon 4 4 pi epsilon naught. 4 pi epsilon naught. This is a value of K. Now what is epsilon naught over here? This epsilon naught. Basically this epsilon naught is permeativity. This is permeativity of free space. This is permeativity of free space, and its value is the value of this epsilon naught is 8.85 exponential power minus 12 Coulomb square upon Newton meter square, right? So it is equal to 8.85 exponential power minus 12 Coulomb square upon Newton meter square, right? Basically this is for the free space. Okay, whenever, okay, this is a value when it is, we are talking about any air or any medium. So whenever, when we introduce medium, when we introduce medium, the electrostatic force force decreases by the amount called relative permeativity or dielectric constant. Okay, when we introduce a medium to the electrostatic, when we introduce medium in this Coulomb's law, so the electrostatic force basically decreases by the amount called relative permeativity or dielectric constant. It looks like this, ER. So basically ER. So when we introduce a medium, when we introduce a medium, for the force in medium is equal to the electrostatic force, which is in vacuum, basically decreases by ER. So this is a value, right? So if I ask you that what will be the force when we are in an other medium other than the free space, so basically the formula would be F is equal to 1 upon 4 pi epsilon naught relative permeativity Q1 Q2 upon R squared. This will be the formula, right? So basically the relative permeativity of air is 1. The relative permeativity of air, of basically space, is 1, whereas of air is 1.0006, right? So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section. I'll be really glad to answer you guys.